particles. We are going to look at determination of particles, but before we do that, I would request my producer to give me slide 5 that I can emphasize some things. You can read there, a must do. Okay, make sure you have a pen, a notebook, and a calculator. Then if you missed yesterday's lesson, you can visit our website www.codehighschool.ac.ug. That is our website. So you can again follow us there if in case you don't get some things very well. Okay? But if you can, please get them now so that you don't waste time. Okay? Invite a friend, invite a brother, invite a sister, attend with him or her this lesson. Okay? Yesterday, the major things we looked at mole concept, and we defined it. We defined it as something that deals with determining the number of particles. Okay? And we said that those particles we have on our next slide. Those particles we have molecules, ions, electrons, atoms, and any other specified particle that you may look at. Also, we looked at some terms that I may repeat now. We looked at a mole, and we said it's the amount of substance that contains 6.02 times 10 power 23 particles. Okay? And that was a major point in our discussion. We said that 1 mole equals that one, and that's where we got our definition from. Okay? We also looked at what they call molar mass, and we said it's the mass of 1 mole of a substance. We looked at also a term called relative molar mass, and we didn't define it yesterday. Now it's time we can define it as the mass of an atom of a chemical element expressed in atomic mass. Okay? And this relative atomic mass can be, you can call it atomic mass, or you can call it atomic weight. It will still be the same. When we go to our next slide, we look at an element. Okay? An element as a pure substance that cannot be split or divided into 2 or more particles, simpler particles, by any chemical mean. Okay? We looked at that one, and that's how we defined an element. On our next slide. Then we looked at formula mass, and we said formula mass or molecular mass. Let me emphasize this one. Yesterday, we were using formula mass. And in the questions I received on net, you were asking, what is molecular mass? Formula mass can be the molecular mass. So once you know how to determine the formula mass, the same as how you can determine the molecular mass. And we say that one is the mass of 1 mole of a compound. Okay? So it is the mass of 1 mole of a compound. And we said a compound is a substance made up of 2 or more substances chemically combined. We defined all those terms. I'm just reminding you of what we did. Also, we looked at so many things, okay? But as for today, I want us to introduce our topic, and we look at the objectives we shall aim at achieving. Today we're going to be having one major objective, that is, by the time this lesson ends, at least make sure you are able to determine the number of particles from a given mass or from given moles, okay? So that's what we are going to look at. Before we look at that one, I want us to again watch the video. Yesterday we watched 1 minute, but I want us to watch it now, the whole of it, and make sure you focus very well and you achieve something. And that's what we are going to be using in today's lesson. Producer, let us watch that video.
Supermarket, we always buy things using standard values. In other words, we always take 1 kilogram of rice or 200 milliliters of fruit juice. Fruits are sometimes counted using the unit dozen. 1 dozen means 12 of something. These are terms used in everyday life. But what if I want to measure something in terms of the number of tiny particles present in it? Let me explain this in detail. Looking at this pure gold, can you tell me how many gold atoms are present in this? Or wait, looking at this glass of water, can you tell me how many water molecules are present in it? You will probably say that it's practically impossible to calculate the number of atoms or molecules in these examples. But astonishingly, chemistry has an answer to this as well. That brings us to the concept of mole. What does it mean? It's very easy. 1 mole of anything has 6.022 times 10 raised to 23 atoms or molecules or particles present inside it. Isn't this number huge? If I have to write down the zeros, this is how big the number will look. 1 mole of anything has these many particles. Now let's say we take a substance which has 3 times the number of particles here. Then we say that this is 3 moles of this substance. And what if we have a substance which has 8 times the number of particles here? That's correct. It will be 8 moles of that substance. That's the basic concept of a mole of any substance. Let's see if you've understood the concept well. Now here's 1 mole of this pure gold. How many atoms does it have? Yes, as it's 1 mole, it will have 6.02 times 10 raised to 23 atoms in it. Similarly, 1 mole of pure water will have 6.022 times 10 raised to 23 water molecules inside it. So is this how we define 1 mole? 6.022 times 10 raised to 23 atoms or molecules or particles? Well, that's the simplest way to understand it. That means if we take, for example, a bag containing 6.022 times 10 raised to 23 hydrogen atoms, then can we say it's 1 mole of hydrogen? Yes, that's right. Similarly, 6.022 times 10 raised to 23 molecules of any compound like copper sulfate is 1 mole of copper sulfate. Simple, isn't it? Wait, we have just understood the concept of mole in simple words. But we are yet to take a look at the scientific definition of 1 mole. And what's this number we referred to? Does it have a special name? Watch our next video to know more.
The video very well and you have understood something. So that's what we are going to use that concept to understand today's concept. Okay? So be with me, be alert, be with your calculator because we are going to do a lot of calculations. Okay? So calculating number of particles, and we are saying that this one is based on the relationship between 1 mole equaling to 6.02 times 10 power 23. That is what we are going to be looking at. Particles, okay? Calculating the number of particles in a given substance, we have to look at the 1 mole equaling to 6.02 times 10 power 23 particles. Please note this one carefully. That's what we are going to be using in each and every question which I'll be looking at. So when we go to example 1, we look at example 1 saying calculate the number of atoms in 8 moles of sulfur. On our slide 12, look at calculate the number of atoms in 8 moles of sulfur. Okay? We are looking at calculate the number of atoms, in 8 moles of sulfur. Right? So we are going to calculate the number of atoms. Remember, we said particles can be molecules, can be atoms, can be ions, can be electrons, can be protons. Let us keep that one there. Particles can be molecules, atoms, ions, or electrons. So for this question is requiring us to calculate the number of atoms in 8 moles of sulfur. So when you go to 1 mole equaling to 6.02 times 10 power 23 particles, that means in this question we shall say 1 mole is equal to or contains 6.02 times 10 power 23, and now the particles we are dealing with, they are atoms. Okay? Now we are saying that 1 mole equaling to that one, atoms. Okay? That means we are going to bring, if 1 mole of sulfur, okay, contain 6.02 times 10 power 23 atoms. Remember, our objective is to determine the number of particles. Now here we are saying to determine the number of atoms, since atoms are also particles. Okay? If 1 mole of sulfur contain 6.02 times 10 power 23 atoms, okay, then we shall say that 8 moles of sulfur will contain or contains 8 times 6.02 times 10 power 23, and these ones are going to be atoms. And what is our answer? Use your calculators to get the right answer. If you do some good mathematics calculation there, you'll end up with a value. Okay? But before we get the value here, can we relate this one to what we have just watched in a video? Okay? If I say one bucket contains 5 mangoes. Okay? 1 bucket contains 5 mangoes. Now we are using this one we want to use this one to understand the concept here in chemistry. This one is what you do in your day-to-day life. Then we said that what about 3 buckets? Okay, let us use the same value. What about 8 buckets? If one bucket is having 5 mangoes, what about 1 bucket? That means 1 bucket is going to be having 5 times 8, 5 times 8 mangoes. And this one will give us 40 mangoes. That's what we are using. That is the same concept we are using. We are saying that if 1 mole contains that one, what about 8 moles? That means 8 moles will be 8 times 6. Alright? To be 8 times 6. And you get the number of more atoms that you need in this. Okay? I hopefully that the concept is being taken, and I want to delay on that one with a reason that I want everyone to understand, so that when we go to the next example, it becomes easy. That will be 48.16 times 10 power 23 atoms. Okay? That means if just 1 mole contained 6, then these 8 moles will contain a higher figure from what you have seen. In the 1 bucket, you find there 5 mangoes. In 8 buckets, you find there 40 mangoes. Okay? And that's the same concept here. Remember, a mole was got from the concept of grouping particles. They saw that particles are living in a large number. Okay? So they decided to group them. And that's what we also do in the market. You don't sell one by one. You sell a bucket or a sack. But you know what is contained in a sack. So if someone is asking for 8 sacks, is knowing what is going to be there. Okay? You can't request for what you can't finish. Right? So when we move and we go to our next slide, we shall meet there another question. Example 2. Let's go to example 2 on our next slide. Hopefully this one you have understood it. So we have had an example on atoms. Okay? We can also have another example. Calculate the number of atoms in 0.25 moles of calcium. Remember, we said this one should be there. 1 mole giving 6.02 times 10 power 23 particles. We shall keep picking it from there. That's what we are using. So when we pick it from there and we go to our example 2, want to answer the example 2, which is having 0.25 moles of calcium. Moles of calcium. Okay? Remember, the first thing to think about is what is in 1 mole. Because 1 mole will give us a way forward. So we go back and say, if 1 mole of calcium, okay, contains 6.02 times 10 power 23 atoms. Our particles now are atoms. Okay? That means 0.25 moles of calcium will contain 0.25 times 6.02 times 10 power 23. 23. power 23. And these ones are going to be atoms. Okay? When we put in our, when we use our calculator, we can be able to get the right answer. Please use those calculators to get the right answer. Don't wait for mine. Okay? Use the calculators to get the right answer. When you calculate, you multiply 0.25 times 6.02 times 10 power 23, you'll end up with 1.5 times 10 power 23 atoms. That means these are the number of atoms which are contained in 0.25 moles of calcium. All right? Hopefully, we are applying what we saw in the video. Okay? And we can now use here the same concept on the buckets of mangoes. Okay? When we move to our third example, we look at the third example is saying calculate the number of hydrogen ions in 2 moles of sulfuric acid. Okay? Our third example is saying calculate the number of hydrogen ions in 2 moles of sulfuric acid. Okay? We are going to calculate number of, you note first what you want, hydrogen ions in 2 moles of sulfuric acid. Okay, in 2 moles of sulfuric acid, we want hydrogen ions. These ions are the particles now we are going to calculate for. Okay, those are the particles we are going to find in this case. So before we do all things, we first look at what is contained in 1 mole of sulfuric acid. How many hydrogen ions are there? Okay, you can see here that we have 2 hydrogen ions. 2 hydrogen ions. That means we have 2 moles of hydrogen ions. Okay? We have 2 moles of hydrogen ions in 1 mole of sulfuric acid. If we have 2 in 1, what about in 2 moles of sulfuric acid? This one is simple mathematics here. What if you have this in 1, if you have 2 in 1, what about in 2? That means in 2, we shall be having 2 times 2 moles of hydrogen ion. Okay? When we put into our calculator or we use our head, we can say 4 moles of hydrogen ions. That's very important. We have to first look for those moles of hydrogen ions. The question is asking us to find the number of hydrogen ions in 2 moles of hydrogen sulfuric acid, in 2 moles of sulfuric acid. So that means we go back to our concept. Now we need those particles. And the particles are the ions. Okay? Want to see if one mole of hydrogen ions, okay, contains 6.02 times 10 power 23 ions. Okay? Have a look at it. This one was to help us to get to know how many moles of hydrogen ions. are in sulfuric acid. Okay? Now here we are going to find out how many particles of hydrogen ions. Okay? So we are saying 1 mole equals that number of particles. That means here we don't say particles, we say ions. Since the particles, we know them. The particles we are looking for, we know them. They are ions. Okay? So we say if 1 mole contains that number, what about 4 moles of hydrogen ions will contain 4 times 6.02 times 6.02 times 10 power 23 ions. You have to apply brackets. Then you get here your answer. Okay? Please put it into your calculators and get the right answer. Give it to me. Our right answer is going to be 24.08 times 10 power 23 ions. Now this is the final answer. Okay? You can see that we are using the same concept repeatedly, but in a different way. Okay? Remember the other side in the video, we saw that in one kilogram of posho is containing a given number of particles. And we saw that even posho, I told you yesterday that posho, when you have posho in your hands, you may say that I'm having posho. When someone is having posho on the plate, he's saying, you will say that I'm having posho. When someone is having a sack of posho, you will say also I'm having posho. But that posho has got particles, and we need to find out how many particles. And we cannot start counting per particle. We need to group those particles. That's why we group them in kilograms. Okay? We say that it is 1 kilogram, there are 2 kilograms, there are 4 kilograms. In a sack, there are 100 kilograms. Okay? So that you avoid that burden of counting 1 by 1 particle. Okay? Because you know sometimes you need to give accountability. So that accountability you are doing, that is the chemistry we have here. Okay? You can apply the same concept and you calculate the number, our numbers here. 1 mole, those particles. 1 bucket containing 6 mangoes. 2 buckets containing 6 times 2, and you end up with the right answer. Okay? We have got that one. We can move to example 4. Okay? Now here we have been dealing with particles. Okay? You identify which particle you want to deal with. Okay? You want to deal with a molecule, you want to deal with an atom, you want to deal with an ion. But now if a question comes, for example, that question number 4, calculate the number of particles in water molecule. I think I can take off this. The last 3 examples we have been looking at individual particles. Okay? Now they are saying that you calculate the number of particles in water molecule. Want to look at water molecule. And we determine how many particles are there. If you remember, yesterday we looked at what is water. Water molecule is H2O. Okay? Water molecule is H2O. Okay? Water molecule is H2O. And that is it. So we are going to look at the number of particles. You see, this question is general. This question is general. We are looking at the number of particles. Okay? That means if you look at this one, particles, we have molecules, atoms, ions, electrons. Okay? That means if we say number of particles here, it is not specific. That means you have to look at which particles are present there. We calculate them. We look at particle number 1. We say there is water molecule. There is a water molecule. We can use now a molecule as a particle. So we want to find out how many water molecules are there, how many water particles are there. We say 1 mole of water, okay, contains 6.02 times 10 power 23 molecules. Okay, look at the question. The question was straight. Water molecule. That means it's only just 1 mole. So for the part of molecules, we have finished that one. That is our first bullet. Okay? So we go to our second bullet. What are other particles that you can find there? We have hydrogen atoms. Do we have hydrogen atoms there? Yes. We have the hydrogen atoms there. First of all, you look at water. Water is containing how many atoms of hydrogen? We have 2 atoms. Okay? That is 2H, meaning it is having 2 moles of hydrogen atoms. It is having 2 moles of hydrogen atoms. Okay? Then when it is having 2 moles of hydrogen atoms, now we say if 1 mole of hydrogen atoms contains 6.02 times 10 power 23 atoms. Okay? 1 mole of hydrogen atoms is containing 6.02 times 10 power 23 atoms. What about 2 moles? 2 moles of hydrogen atoms. That means these ones will contain 2 times 6.02 times 10 power 23 atoms. Then we'll be able to get 12.04 times 10 power 23 atoms there. Okay? That means hydrogen atoms, we have the hydrogen particles, we have 12.04 times 10 power 23 atoms. Okay? Remember we said you have to calculate every atom which is there. Now we look at water. It is having hydrogen and it is having oxygen atom. Okay? Oxygen atom. In water, if you can look at the chemical formula, you realize that there is 1 mole of oxygen atom. There is just 1 mole of oxygen atom. And now, since there is 1 mole, we shall say 1 mole of oxygen atom contains 6.02 times 10 power 23 atoms. Okay? So, when they say calculate the number of particles in a water molecule, they have not been specific. So you have to calculate all the atoms in order to get all the answers, all the marks needed. You have to first calculate them. You go and say, what are the particles I need to calculate for? Molecules, atoms, ions, electrons, protons. Then you find out, what do I have here? I have a molecule. Water is a molecule, okay? Then I have what? I have atoms in it, okay? I have the hydrogen atoms, I have the oxygen atoms, okay? Then you go ahead and calculate the number of particles in the respective atoms, molecules, elements present, okay? That was our example 4. Okay? When we move to our example 5, we shall look at what they call oxygen molecule. Okay? We look at what they call oxygen molecule. It is also saying that calculate the number of particles in oxygen molecule. Can take off this. Told you to be with your calculators so that we calculate these numbers. Okay? Because this topic involves a lot of calculations. So don't enter a chemistry paper without a calculator. And please write well. If you don't know how to write, I encourage you to buy a new book during this holiday, and you do what? And you practice how to write. Copy from a neighbor, okay? If you don't know, accept that you don't know, and you'll be able to learn. Because when you insist, you'll end up writing correct answers, but in a bad handwriting, and someone may not give it time. You may end up losing marks, okay? I continue to encourage you to stay home in order to stay safe. Let us look at example 5, which is saying calculate the number of particles in. It is saying calculate the number of particles in 2 moles of oxygen molecule. In oxygen molecule. So what do we need to know here first? We need to know what is the chemical formula of oxygen molecule. The chemical formula is O2. Okay? Remember I said when the question is saying calculate the number of particles, you have to first know what are those particles present. Now once you get the chemical formula of the molecule, you understand that there is a molecule and there are also atoms, oxygen atoms. So let us begin with the molecule. We say 1 mole of oxygen molecule contains 6.02 times 10 power 23 molecules. Okay? If 1 mole is containing 6.02 times 10 power 23 molecules, what about 2 moles? 2 moles of oxygen molecule will contain 2 times 6.02 times 10 power 23 brackets. You say molecules. Then you calculate there and you get your 12.04 times 10 power 23 molecules. Okay, so particles, we are now calculating for the particles. Remember our objective is by the end of this lesson, we want everyone at least to be able to determine the number of particles, either using a given number of moles or given mass. Okay? So if that one is over, we go to the next one. We say, let us look at atoms. If one mole of oxygen contain 2 atoms of oxygen. Okay? 2 atoms of oxygen. That means 1 mole of 2 moles. No, we have looked at 1. Now 2 moles of oxygen molecule will be containing 2 times 2, how you say, moles of oxygen atom. Okay? If 1 contain 2, that means 2 will contain 2 times the 2, which is 4 moles of oxygen. So once we have 4 moles of oxygen atom, okay, we shall now go back to our principle. 1 mole contains 6.02 times 10 power 23 particles. We say 1 mole of oxygen contains 6.02 times 10 power 23 atoms. Okay? Now what about 4? What about 4 moles? 4 moles of oxygen atom will contain 4 times 6.02 times 10 power 23 atoms. Here I'm moving a bit fast because this one now it is becoming the usual math calculation. Okay, everyone can do it. Since now we have had examples, once we get now the logic which is behind this question, once you understand that I need to look for particles which are molecules in it and the atoms, the rest becomes simple. Then here when you calculate, you get 24.08 times 10 power 23 atoms. If you can look at these answers very well, the answers we have been getting, they are repeating themselves. Okay? It is the same mathematics we are applying in all. Okay? That means to pass chemistry, you must also concentrate mathematics so that you get how to calculate these things. Because when you come to chemistry and you know a bit of mathematics, life becomes easy. So subjects move hand in hand. Also chemistry also can borrow some knowledge from biology, can borrow some knowledge from chemistry, even from English as a subject, because you need to be able to interpret the questions and you be able to write where on the questions requiring you to explain and describe a given number. Okay? Hopefully we have finished that one. So we have been having examples involving calculating the number of particles from given moles. Okay? Now we want to look at an example involving calculating the number of particles from a given mass. Okay? So that we'll be able to achieve our objective very well. Remember, our objective is we should be able to determine the number of particles from a given mass or given moles. So let us look at example 6 and we see how we can do it. Okay? Our example 6, those are the calculations we have been doing. So these slides will be uploaded on our website, that is www.codehighschool.ac.ug. Visit it and check for this work. Okay? All the calculations are there. You can see them so that you can be able to read if you are not following very well. Okay, the step you missed, you'll get it there, but hopefully you have understood this. Let us go to question 6. Please, I continue to encourage you to stay home. The students who are at home, please don't give up. When the term resumes, we shall resume our normal work. But at least you should be somewhere. If you know that there was a topic challenging you, it is the time now to concentrate on that topic. Okay? It is the right time now to concentrate on that topic so that you can be able to achieve what you want to be in future. Okay? Please don't forget what you want to be in future. Stay home and keep focused. Right. So the question is calculating the number of particles from a given mass. And our question is specific. We are saying calculating the number of atoms from 0. We say number of atoms from 0.4 grams of oxygen. Okay? From oxygen atoms. Okay? So it is not saying oxygen molecules, it is saying oxygen atoms. It is straight. Okay? There is a difference between oxygen molecule and oxygen atoms. Please take note of the two. Oxygen molecule is 0, 2, O2. Okay? Oxygen atom is just the O, capital O. Okay? So that is it. So don't confuse the two. Make sure you be able to distinguish them. So the question is saying we calculate atoms from those number of grams. But remember, we said this one is going to be the major point. All calculations are going to be based on the relationship between this one. Okay? So we go back and say if 1 mole, okay? If 1 mole of oxygen atom, okay, contains 1 mole of oxygen atom contains 6.02 times 10 power 23 atoms. Okay? If 1 mole contains those number of atoms, what about 2 other moles? Okay? What about other moles? Okay? But you look at our question. A question is clear. Atoms from grams. So here, that's why I want to go back to this one. The atomic mass of this one, the relative atomic mass of oxygen molecule is 32. The relative atomic mass of oxygen atom is 16. Okay? That's very important. Because once you bring this one, you get a different answer. So you should be able to pick this one. That means 1 mole of oxygen atom. And what is the relative atomic mass of oxygen atom? It is this one. Okay? That means 1 mole, once you say just 1. If you say I have 1 mango, and they have told you 1 mango is weighing 2 kilograms. Okay? That means you have 1 mango. So if you change that 1 mango and you put it in the language of grams, okay, you say I have 2 kilograms of mangoes. Okay? All right? Or if you have just 1 sack of posho and you say I have 1 sack of posho, but someone say how many kilograms of posho do you have? You should be able to say I have 100 kilograms of posho. So you say here it is 16, you have 16 grams of oxygen atom contains, okay, contains 6.02 times 10 power 23 atoms. Here we are not calculating because we are not moving from N. We are just changing this one to this one. So here you have to first determine 1 gram of oxygen atom contains how many atoms, okay? If 16 is containing that number, that means this one will reduce. If a full sack is having 100 kilograms, what about half of it? That means the grams will reduce. Now here also this number will reduce. We said divided by 16. And those will be the atoms. Okay? So once we have 1, we have what is in 1, we can be able to find what is in 0.4 grams of oxygen atoms. And we say they contains that is 0.4 times 6.02 times 10 power 23 divided by 16. Okay? Can we use our calculators to get the right answer? Okay? Be able to get 1.5 times 10 power 23 atoms. Okay? That is how we get it. Please, let us play for me slide 25. Slide 25. Slide 25. Producer, slide 25. We want to look at our objective. Our objective was we should be able to determine the number of particles. Slide 25 on a full screen. Let's that point, have we achieved our objective? Are you able to determine the number of molecules from a given number of mass or from a given number of moles? Okay? Please play for me the last slide, the next slide, having the exercise. Next slide. On our next slide, we have the exercise. Please make sure you do that exercise. If you have not been able to copy it, go onto our website and visit the website, download the PDF so that you can be able to do our exercise. Okay? There are 3 numbers. Do them. Make sure you practice. Parents, I request you to supervise them. Make sure those students attend to those exercises. I've remained as Saul Chamanywa, chemistry teacher. We meet again tomorrow at the same time. Thank you.
Television, your family network. Omusumba Jackson Senyonga ategeeza abantu mwenna nti kati musobola okugoberera service za Christian Life Church okusaba copy 5 wamu ne programu za Pastor Jackson Senyonga ez'enjawulo ez'oku TV ne radio ng'oyita ku mikutu gye mugatta abantu egy'enjawulo giyite social media platforms ku simu yo, kompyuta yo oba ekirala kyonna. Ku Facebook teekamu Pastor Jackson Senyonga Ministries, ate ku YouTube teekamu Pastor Jackson Senyonga Ministries, ku Airtel TV ate ku MTN TV genda ku Yo TV era oyinza okukyalira emikutu gyaffe nga www.topradiouganda